Electrical safety isn't something you can ignore. So, what can teams do to stay safe? Alan, that is exactly where I'm going to have to lean on you for this one. How can teams really create environments that mitigate electrical hazards?
Yeah, so I guess that one probably comes down to planning. The earlier and more so earlier in planning, right? Planning early, planning ahead of time, so that you can actually apply some of these concepts. The later you get in the stage and the closer you get to the activity that is hazardous, the less you're going to be able to do. So think of the hierarchy of controls. If you only have minutes to adjust, that's like a PPE, right? You can throw safety glasses on, you can wear gloves or not wear gloves depending on what it is, right? Like table saw, if you don't want to wear gloves. But the earlier you can plan, the higher you can get up in that hierarchy of controls to potentially even eliminate the hazard altogether. So the earlier you can plan, the better.
Right. Let's say that people are looking to reduce risk from the front of the building to the back of the building. How can safety products do that without sacrificing productivity?
The more you can automate and the more you can do that automation with thought and intention about a specific hazard, the better. And the key about automating is removing the human factor, right? Typically, safety comes when something goes wrong, whether it be a human error, driving, you look down at your phone, you probably shouldn't have been doing that, and all of a sudden, cars are braking in front of you. Had you not looked down at your phone and created that error, it probably would have been not an issue, right? Because you would have broken time, you would have seen the red lights. There's examples all over that for that, but human error is the issue. So anytime you can automate that, whatever you're applying, the better. Safety processes can't be obtrusive, cumbersome, or someone's going to bypass it. So again, automate and getting us out of that, whatever's causing that hazard or exposing that hazard, the better.
So I think you're probably the perfect person, and this is the reason that we're talking if we boil it right down. When it comes to AVTs or absence of voltage testers, it feels like VeriSafe is just the go-to option. Why is that?
I mean, when you think about what VeriSafe was designed to do, it was designed to automate and eliminate the hazard from the person and the person from the process. So with absence of voltage testing, that live dead live process has been around a long time. There's been different attempts to improve the process throughout the years, but the human error is still in there. With VeriSafe and AVTs, it's not. So that, going back to the previous comments, we had enough time to plan. We were able to get really high up in that hierarchy of controls. We didn't eliminate or substitute electricity because that's a whole different level of planning and effort there. But we got to that engineering control where we're able to have a device that eliminates the human factor and it eliminates the cumbersome part of live dead live testing, and it automates that whole process. So one of the nice things that AVTs do, or VeriSafe does, is it validates when you press that button, it validates that it's working properly. Very much like when you turn on your computer and it goes through the DOS prompt and it makes sure that the hard drive's talking on the motherboard and all that stuff. And if it's not, it's going to go into safe mode, or you're going to get a blue screen of death, right? Something's not working. VeriSafe verifies that when you push that. Every time you push the button, it verifies that it's functioning properly. And it also goes through another step and verifies that it's connected properly. So you won't ever get a case where you're going to get a green light saying that it's safe, and then you go in and those leads aren't connected to the conductors. It always will know, because that's one of the steps of the process. That is something that you don't get with the traditional, portable meter, where you have to rely on your own human factor to make sure you're making good contact. And going back to previous questions, that human factor is what causes the issue. We are not good at doing a consistent process the same time every time with the same result. We can do the process, we'll just get a different result.
That is the problem with us humans, isn't it?
Yeah, right.
Well, Alan, I've taken more than enough of your time. Thanks for talking today.
You bet. Thank you. It was a pleasure.